Can everyone hear me okay? Yeah, cool. All right. Hi, guys. My name's Ben. Thanks for coming. I work at HubSpot, and I'm here to talk a bit about how to build rich text editors in React while not having too bad of a time. So I broke up the talk in a few parts. First part is about ContentEditable, some challenges it presents, Draft.js and how it attempts to resolve those challenges, and some next steps to make it easier to kind of integrate Draft into your app going forward. So rich text editing is not a new problem. It's been around for a while. There's a few libraries we've used in the past in various iterations of HubSpot to solve these problems. One of the most notable ones is TinyMC, which has been around for a while. It's pretty full-featured, has a lot of community support. A more lightweight approach we've used also is Summernote, which is a jQuery plugin that uses Twitter Bootstrap and is just a lightweight approach, not as many features, just kind of more quick and dirty. But there's a key commonality between the both of the two, which is that they both use ContentEditable without a lot of moderation in between. So ContentEditable is an HTML attribute that allows you to basically, you put it on a node and then pass in React, you pass it in dangerously in HTML like this, and it basically gives the browser in-browser edits and full reign over the content of your node to the browser to edit whenever they want. And it turns out that caused a lot of problems, especially in React. So the biggest problem it has is that it's using the DOM as a source of state. So any sort of changes that the user makes are just in that element and not really, it's hard to track from React. It's like the most uncontrolled component you can really have. It also, and this creates a bunch of kind of downstream problems, like really messy HTML when you're letting the browser handle all the HTML transformation, and also extensibility gets really weird to get the features you want. So instead of having this as your output representing the white space in your editor content, you might end up with something like this, which gets pretty chaotic. And instead of having some working personalization token-like feature like this, you might end up, after a few interactions from the user, with something like this when they don't mean it. So things can get pretty hard to manage really quickly. And these are solvable problems with these frameworks, but it's just like not a great way, in my opinion, in React to spend your calories. So if only there was a better way, a way that handled this for you in 2017. So fortunately, last February, Facebook at ReactConf announced Draft.js. I recommend checking out their talk, which will go into a lot more detail than I can in 10 minutes about why it's great. And it's their kind of attempt to resolve these issues. So it's a React rich text editor UI framework. They use it pretty much throughout their product. I believe Messenger.com and any status update places. Pretty much anyone you can do an @ mention or a hashtag in React or in Facebook, they use it. So yeah, so things like this. And it does a few things nicely that solve this problem. Namely, they separate the editor state from the DOM. And this is a lot more in line with like what you want to do with React, which is have DOM be a function of state, pure function of state. And so the way they do that is they make this immutable data structure that represents the content of your editor at any given time. So it looks something like this. It's called an editor state, and it's separated into a content state, which is really the actual content of your editor. So, and it's split up into these blocks that, so in this example, they correspond to each paragraph there. And then it also has a selection state. So this actually represents the position of like the focus of your editor at any given time. So it's a much more like controlled approach to handling this, like we were mentioning before, the accessibility stuff, where focus is kind of a thing that's not really handled too well by React. So this is actually like much more finer control over that. So one of the other nice consequences of this is any sort of features or in your app or user interactions can be described by this pure function operation that transforms that state. So Draft gives you a bunch of kind of small primitive pure functions that you can use and compose together to build any sort of feature you want. So things like replace text, like add metadata to a range, anything like that, and putting those together lets you really like focus on actually building your app rather than like working around a bunch of kind of browser inconsistencies or things like that. So it lets you get a lot more consistent experience out of your rich text editor without having to spend all your time working on it. And it also lets you build arbitrary rich text. So there are a bunch of hooks that Draft gives you to build any sort of feature you might want going forward into your editor. So that's a little bit about Draft. So at HubSpot, we were looking to integrate it into our project, and we found there were a few things that we needed before we could just take the editor component that Draft gives us and replace our old editor component that we had with TinyMC or Summernote. So the most notable reason that we couldn't just throw it into our app was there's no HTML output. So when Facebook uses, to my knowledge, when they save Messenger.com messages or anything like that, they're just storing a JSON representation of that immutable data structure. So it's not ever actually saved as HTML at all. And so that works for a lot of use cases, but for things like email where you actually need to send HTML, this doesn't work, and that's one of our use cases. So it was pretty important to us to have some HTML output. It also gives you a bunch of primitives to work with to build these features, but there's not a great way to abstract them, and there's also really not a ton of modularity in the built-in options. So you end up reinventing a lot of wheels, and then while reinventing a wheel, you might break another wheel you reinvented previously, and you run into a lot of issues. It gets really brittle really quickly, especially across a bunch of teams where you don't need everyone to know how to build every draft feature from the ground up. So these two issues kind of get summed up in the whole, just having plugins would be great. So our solution for the first conversion issue was Draft Convert. So Draft Convert is a way to extensively serialize draft content to and from HTML. So it gives you a bunch of hooks that you can use to go to define the conversion logic for any features that you're building. So this includes things like blocks, block types like images, inline styles, any sort of formatting, and entities, so things like at mentions or links where you have to apply metadata. You can define exactly how you want to convert to and from using either React components or just strings. So if you have a personalization token, like I mentioned earlier, you can represent it, you can serialize it down to this kind of text pattern, and you can go to and from matching on that as well. So it's pretty easy to use. You basically just provide a bunch of options, and that gives you a function you can use to convert to and from HTML. So the other two issues I mentioned are kind of just summed up by, it would be great to have some way of defining plugins that you can use across teams to put features in your app. So the most popular option here is Draft.js plugins, which is a community open source a project that kind of spawned right after Draft was announced. So it's a plugin platform as well as a set of plugins. So there are a bunch of community plugins that you can use and get going really quickly for common features like app mentions or emojis or something like that. And there's a bunch of people actively developing on it. And it is compatible with the conversion stuff I mentioned earlier, Draft Convert, but it's not quite integrated. So you need to have kind of two definitions of what your features in your editor are, where you have the actual component definitions in the plugins, then you'll also have to write your own conversion logic. So a combination of that not being quite integrated and us also using at HubSpot our own UI library, as most of us are, meant that we were going to probably have to rewrite our plugins anyway. So in the process, we ended up writing our own plugin platform that we call Draft Extend. So it integrates serialization into configurable and extensible Draft.js editors. So there are currently no ready-to-use plugins, mostly for the same reason, we ended up using it with our own internal library. But it creates a bunch of plugins that are composable high-order components. And they integrate pretty well with Draft Convert. So when I said they're high-order components, you basically create it with this factory function, and it gives you a plugin that you can wrap around your editor component, and it returns a better editor component, basically, with all the features of your plugin. So the cool thing you can do is you can also wrap these around with a little special stuff in the plugin. You can wrap it around the conversion functions as well. So then you have this, you pass in the conversion function, it gives you one with all the features of your plugin. So that means you can do some cool stuff like you see the plugin group there is like a plugin that wraps other plugins and returns a bit like a better plugin. And also you can compose these all together in the single definition of how you want your editor to work. And then you can use that everywhere you need. So we found this to be really nice when deploying this across a bunch of teams and a bunch of apps pretty quickly without having them have to know how all of Draft works. So just to wrap up just to recap all the things I mentioned there. So Draft.js is the core library by Facebook. Draft Convert is our extensible conversion library. Draft.js plugins is the community plugin platform. And Draft Extend is the plugin platform with conversion integrated. And here are a bunch of the links for those. So some calls to action. Check out Draft. I think it's a really nice way to build rich text editors in React in 2017. Contribute to the plugins and platforms. All the things I mentioned are open source, so there's always lots of work that can go into all of those. And also, if you're getting started with Draft, check out the Draft.js Slack org that they link on their GitHub page. It's a good resource for if you're getting started and running into any issues going forward. And that's pretty much it. Thanks. Okay, also, I don't have time for questions, but if you have questions about Draft in general, I'll be around later. Thanks.
All right, can everyone hear me? Sounds like it. Okay. So my name is Matt DeGennaro. I work here at Wayfair, and today I'm going to talk about Babel transforms. I work on the tools and infrastructure team here at Wayfair, and so what we do is we don't really develop code for our end users. We develop tools for the other developers at the company to use. So we try to write tools that simplify their workflow and just make for a better overall developer experience. And so for someone in my role, Babel is kind of awesome. Now, for the 0 of you in the room who don't know what Babel is, it's a tool to convert ES6 and ES7 and JSX into browser-compatible ES5 code. And if you take a look at the popular NPM packages for it, that really makes sense. It's all modern features that allow you to transform, allow you to write modern code and still have it work in the browser, even if you have to support IE9. And that makes sense because that's its motto: use next generation JavaScript today. But for me, it's a lot more than that. This quote really sticks with me. It's Babel allows us to enhance both the user experience and the developer experience at the same time. This is a really old example. It predates the REST operator. But this was from an old article about V8 optimization killers from the Bluebird Promise library. So they had to convert the arguments object into an array of arguments a lot. And they were very performance focused. So instead of having their developers copy and paste the boilerplate from the second snippet over and over and having to code review that over and over again, what they did was they had a build time step that converted the fake global method inline slice into the boilerplate. And what this let them do is make sure that it was always going to be accurate, it was easy to update if they ever wanted to do anything different with it, and that they didn't have to worry about their developers accidentally making a typo and bringing down the whole library. A more modern example, but a similar premise, is Lodash. Lodash is a great library, and they have a build that allows you to import only the methods that you actually need to use. But this gets annoying when you have a module that requires 5, 10, 15 different methods because your import block at the top just continues to grow and grow. So Lodash has a plugin that allows you to just import underscore from Lodash. Just use whatever you need from it. It has everything on it. And then at build time, they just reduce that down to you used add, you used map, so we're going to import those and get rid of everything else, which is kind of like tree shaking, but without the need to actually do the tree shaking. It gets rid of 98% of Lodash because you're only using the 2 methods. And so as we're facing problems here at Wayfair, we try to keep this in mind as an option for stuff we can do. So when we were converting our code base into React, one of the issues that we faced was internationalization, which I'm sure is something that a lot of you have had to deal with. When you're dealing with React, your markup and your data really starts to intermingle, and you likely have to deal with a translation system that predates your employment at the company, and so that can't really change. The gut reaction was, well, we can just use dangerously set under HTML, except that's terrible, because you're basically letting your users XSS cross-site script themselves. And it's just really hard to tell from looking at this, what is this supposed to be? The key name is feedback with link, but if you're just skimming through the module quickly, it's really hard to tell what this is supposed to be. For a minute, there was a suggestion that we could just translate the individual strings, but that doesn't work because you lose all context for the translators who just have no idea what you're trying to do. So we came up with the idea that what if we could just have a JSX component that would wrap the whole string that needed to be translated and just do some build time optimizations on that to allow us to stay within JSX context. And so we took a look at Babel plugins, and with a lot of help from AST Explorer, which is a fantastic website for when you have no idea what the AST looks like, we were able to come up with something that essentially flattened the string into the string literals and any JSX components so that we could preserve those, send the strings off for translation, and then replace it with a block of code that I wouldn't expect any of our developers to have to write by hand, but it works as the end result. So the developer gets to write something easy, the customer gets something that works. But there's more to this that you can do. There's more than just taking code and outputting other code. You can extract data from your code while you are writing it, while you're building it. You're able to save data off onto metadata and extract those into their own build artifacts so that you can use that data on systems that don't know anything about your JavaScript or aren't written in JavaScript if you have something else on the back end. And so you can do some really cool things with that, like figure out what the adoption rate of your code is, because you can do things with grep and with regex, but unless you are really, 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 really good at regex, it's not going to be anywhere near as accurate as the AST parser. You can also do things like determine the hotspots of your code, which things are being imported the most, which functions are being referenced the most, and make sure that that lines up with your unit test coverage so that your site doesn't break. But you can also do some other stuff, and probably the coolest thing that I think we're doing with that right now is streamlining our GraphQL setup. So GraphQL is a really powerful tool, as you've heard at a number of talks here this weekend. But the more data that you're requesting, the larger the query that you have to send up to the server winds up being. And so when you have to send stuff like this up for any particular product block, it gets a little messy. But again, we don't want our developers to have to go out of their way to optimize this. So what we do is we have it in a tagged template literal, which we need for Apollo anyways. And we're able to process it out so that we create a generated ID based off the module name of the query, and we leave that in the code base, and then we extract the generated ID and the raw query so that we can save it off to the server. And then instead of sending this over the wire, we're able to send this, which hopefully to the untrained eye looks a lot smaller. It goes from about a kilobyte to about 100 bytes. So we can get 10 products for the price of one. And it ensures that everything is always going to be accurate. We can do analysis when we're compiling it to make sure that the query matches all of our schemas. And we're able to just put in a very small amount of code. So in summary, Babel is a really powerful tool for augmenting your code base beyond just going from ES6, ES7 back down to ES5. And don't feel limited to the plugins that you can find available on NPM, because a lot of them are only for general use cases, and some of them are a little silly. Like there's one that minifies any references to infinity down to 1 divided by 0 to shave 5 characters. It's probably useful if you have a very math-heavy library, but not the most useful thing across the board. So really try and get creative to make the best developer experience you can for your code base. Thanks.
Good to go? Whoa, okay. Hi, I'm going to be talking today about analytics, in case it wasn't obvious. Quick poll, how many people have ever heard or read the book The Lean Startup? Okay, good numbers, like 40%. The other half doesn't care or anything. So The Lean Startup, a lot of what I'm going to talk about today a lot of the ideas are similar. So if you've read it or if you've heard of it, about half my talk is going to go over the same concepts. So if you've ever worked in a product company or a consulting company, chances are you've seen Jira and you've seen analytics, sort of user stories where you have to set up analytics, either adding a new event or setting up a new tag like Google Analytics, Google Tag Manager. About a year ago, I got a lot of these, and I was really unhappy about them. I didn't like it for two reasons. The first reason is that I didn't think that these were as valuable as feature stories. So I wanted to do like things that users would use. I didn't really care what a business analyst wanted. I know that's bad, but it's the way I felt. The second reason is that whenever I had to do these types of stories, I'd always have to deal with an SDK. I remember one time I got an Omniture SDK and it was in a PDF, and I was really upset. And like the browser support was Netscape, and I was like, what's going on? This is like 2016. Anyways, yeah. So I got a chance to work on the analytics team at Wrangle.io, which is the place that I work, and I had a chance to research a bunch of stories on and read books on why analytics is important, and sort of my mindset has changed. So I don't have time to go over all the stories that I have. I do have time to go over one story, and I hope you like it. So this story takes place in San Francisco, 2010. That's 7 years ago now, almost 8. Jesus. So it's, yeah, so this was, the iPad came out this year. jQuery was version 1.4, if you guys remember that. What else? Mark Zuckerberg was Time Magazine Person of the Year. And the two protagonists of the story is Mike Krieger and Kevin Systrom. So hopefully you guys don't know who these guys are. But these two smart guys, they both met in Stanford. They decided, Kevin was working at Google. Mike was fresh out of school. They decided to start a company together. So they started a company called Bourbon. And basically what it was kind of like Foursquare. It was an app. It was actually a web app before it became like a mobile app. And you could share where you are. You could share where you're going. You could earn points and achievements. I don't know how that worked. And then you could have like an optional feature where you could share photos. Kevin Systrom, so like I mentioned before, he used to work at Google, and he worked on the product team at Google. And at that time, Google was one of the few companies that was using data and analytics to improve their products. And when he started Bourbon, he had the foresight to add analytics to each of the features that they were adding. And then after a while, they found out that people weren't using the app. Andreessen Horowitz was getting angry at them because they invested $250,000 in them. So they went to their analytics and they wanted to understand why. So they found out that people weren't really caring about sharing where they are. They didn't really want to share where they were going, their plans. They didn't understand earning points and achievements, neither do I. But they were sharing photos. So a lot of people that were using the app, they were only using that one optional feature that they just did in one weekend. So they pivoted. They said, okay, we're not going to worry about these 3 other features. We're going to just focus on this one feature. And then, suspense, they came up with Instagram. So they rebranded Bourbon, and then they released Instagram. So this story I really like because it teaches you the power of analytics, and it's not just enough to build something, you have to measure how successful it is. So now whenever I get those stories, I'm kind of half happy. I'm like, I understand why I need it, but I hate dealing with analytics, it's always a pain in the butt. And this is where Redux comes in. Redux is pretty powerful. Because you have access to all your actions. So, you have access, you have a good view into all the state changes in your application. So if you have a to-do app and you have 2 list items, and when you add a list item, you have access to that. So you basically have access to everything that you would want to track. All you need to do is you need to tap into those actions. And during my time at the analytics team at Wrangle.io, I built a library that did just that. It's called Redux Beacon. So what it does is it listens to every action that's coming in your application. And granted, this does depend on how much you use Redux and what you use Redux for. But typically, if you're using Redux for tracking non-ephemeral or non-temporary state, you're going to have access to most of the stuff that you want to track. So that's what Redux Beacon does. It basically maps actions to targets. Maps actions to events. And it sends it off to a given target. So the problem that we had at Wrangle.io is we first built out middleware that was specific to one target, so segment.io. Then we realized like every other client that we have has another target. So we built the library or middleware that supports every target on the planet. So it has support for segment.io. I think we have 7 targets now. Google Tag Manager, Google Analytics, Amplitude.io. And it's pretty simple to make your own target. So I'm just going to go over the API right now. There is no API. There's just this function. It's called an event definitions is what I like to call it. You basically get the action, the previous state, and then what's not shown here is you get the next state too. And then you return an event object. And then the shape of the event object depends on what target you're hitting. So this is an event object that's headed to Google Analytics. And after you create that event definition, you just have a simple POJO where you map it to a given action type. So you have a page changed action type. If you're using Redux router, you're going to have like an @location_change action type, and then you're just going to match it to a page view or whatever other event definition you have. So you're just going to have this big events map, which maps action types to these event definitions, which are just functions. And the last part, which is really the only part of the middleware that has an API, is just the create middleware function. Then you pass it the events map and a given target. So you can have an events map and then pass it to Google Analytics, or you can have an events map and pass it to Google Tag Manager, Amplitude.io, or whatever custom target you want to build. Yeah, so Redux Beacon, it supports every analytics platform. It works well with React Native, so we actually have it in production in a React Native app right now. And it has one of the coolest features that I think, which I think is the only analytics library that does this, is it has offline event tracking, at least only analytics middleware that does this. So if your users, like for example, they're doing something on a train or like in an area which has shoddy connectivity, they can do whatever they want, and then say they go under a tunnel, they lose connection. What Redux Beacon does is it has a system where you can store those events that were offline into AsyncDB if you're on, or async storage if you're on React Native, or IndexedDB if you're on the web, or local storage if you want to go that route. Yeah, and then once your user gains connectivity, they leave the tunnel, the events get purged, and they get sent off to analytics, to like Google Analytics or Google Tag Manager, or whatever you want. Yeah, so now I'm really excited about analytics, and I hope the next time you guys see this, if you're using Redux, please give Redux Beacon a try. It's relatively new. We're adding it to every single analytics project or every single new project at Wrangle.io. So it's going to be well supported. The documentation is pretty good, or at least I think it is. But if it's not, make a PR. Also, if anyone here is interested in doing open source for the first time, I can give you work because I have tons of it. Yeah, just to finish off, I work at Wrangle.io. It's about 170 developers. I think it's the biggest JavaScript-only shop in North America. So if you're interested in talking about that, you can talk to me about that. And I think that's it. OK, thank you.
Cool. All right, so we're running a little ahead of schedule because we had one speaker couldn't make it. So we're going to go straight into the next talk with Brendan about TDD. And then assuming that's on time, we'll give you guys a short break between then and the last 2 talks.
There it goes.
Jiggle the cable. All right, cool.
Hello? Okay, that's on. Hi, everyone. My name is Brendan McLaughlin. I'm an open web developer at Boku, where I help clients build modern web applications by being embedded in their teams. and as you might have guessed, I love testing. Brief overview of this talk. Going to give it like a brief intro to what actually is outside-in test-driven development. Then we're going to talk briefly about some React testing tools. And then we'll get into the meat of the talk, where we'll learn what to test and how. And finally, we'll see how to do a workflow of test-driven development in action. To start off, what is outside-in test-driven development? It's a technique where you start off with the kind of the top-level object in your system. You mock out any dependencies you might have for that, and as you run a test, and then you write your object to implement that test. Once that's done, you repeat the process again with the dependencies you've mocked out, and you keep repeating until a feature is complete. But how does that work with React? Well, I like to start with an acceptance test. This is a very high-level test. It integrates the entire application and just basically tests that everything is hooked up correctly. Below that, I'll use a component test. And this is an isolated test for just that top-level component. When I'm writing this test, I will mock out any APIs I want Redux or something else to inject into my component. And then I'll also mock out the dependent components that this one will delegate to. I'll repeat that process for all of my components in the feature. And then when I'm done, I'll move on to writing some tests for Redux and using them to kind of test the action creators, selectors, and reducers as a unit. So it's really testing the API that's going to be exposed to my components. Now talk about some tools. Jest is a very simple test runner that really gives you everything you want out of the box. If you're using Create React App, you're probably already using Jest. If not, you should definitely give it a try. Here's a simple Jest test. There's kind of like two types of things that we're going to see today. The first one is we just make some assertion about the state of an object we've created. That's the first test. And then the second test is we're going to make a mocked function. We're going to call it and have an assertion that it's called. We can run that with Create React App by just doing npm run test. If using Jest standalone, you can just use the Jest CLI to run it. When we run it, we'll get a nice passing page like this. But then we can go back into our test and mess it up. Change the end to 1, or don't even call our mocked function. If we run it again, we'll get a nice error. Expected value to be null, but instead received 1. Expected the mocked function to be called, but it wasn't. Enzyme is another tool I like to use with React. How many of you here are using Enzyme? That's pretty good. So with Enzyme, at the basic level, there's two types of tests we write. We set up our component, render it with some props, and then we assert about the state of the component we've rendered. The second kind is we set up our component, we simulate an event using Enzyme simulate function, and then we assert that the behavior is written. For those of you who haven't used Enzyme, it's a JavaScript testing utility for React that makes it very easy to do this like assertion, manipulation, and traverse our React components output. All testing is about isolation. I want you to write that down. From a user's perspective, our app is a complete experience. However, we as developers know that we can pull it apart. There's boundaries in our app. Typically, these boundaries are found along feature lines, and we can take advantage of this when testing. It's easy to test separate features separately because we're developing them separately most of the time. We rarely develop all our features at once. But there's other boundaries in our app too. We have different layers, and we can take advantage of that for testing as well. Here are some typical layers in a React app. We have React. It might be handling the UI and DOM manipulation. We might use Redux or some other Flex implementation to store our domain models or persist state amongst components. Then we have various other pieces, the business logic, validation, formatting. And we can actually test all of these individually. Here's some ways we can isolate these tests. I like to write component tests to isolate my React components. I typically test them isolated from each other. We can also write tests for Redux and test the API that's going to be exposed to the rest of our app and our components. Then we can use normal JavaScript unit tests to cover our business logic, our validation, and our formatting. Here's a simple app that we're going to use to demo some tests. It's a podcast app. It lists some podcasts. There's a play button. When you click it, an audio player appears at the bottom, and we'll begin playing the episode. First, we're going to talk about how to test components. The basic idea is you use Enzyme to render the state tree with some props, and then you make assertions about how your component was rendered. One good rule of thumb is that you should try to test both sides of any conditional you have in render. The second way is to use simulate to trigger an event, and then verify that the behavior is what you expected. Here's a nice audio player element. It says if it sees an episode property, it's going to render. If there's no episode property, it's not going to render. So we can write a test for that. Here's our test. In the first test, we rendered the audio element. We're not passing in any episode property, so we expect it not to render. In the second test, we do pass the episode property, so then we can go and look for the episode title, and we expect to see that. If we run our tests, it should pass. Here's the second test. This time, we want to test the behavior of the component. We start by rendering our component with the episode. Then we find the play button and click it. At this point, some internal state has changed in our component. So we want to look for a pause button and make sure it's displayed to the user. We can add this to our test suite and run it as well. Here's some advanced advanced tricks. Oops. So we've seen the kind of query and simulate, and they're really the bread and butter of testing with React components. But your app's going to have lots of components, and as you try to write tests for all of them, you might need some more advanced techniques for helping you create these tests. These are three things that I like to do. I always try to isolate all of my React components from Redux, Flux, and other components. I try to use default props as a test theme. I'll show you how to do that. And finally, I like searching for component names as strings. We'll see what that means. And when you use Enzyme, there's three methods you can use to render a component. It's got shallow, mount, and static. When you use shallow, it's going to render your component out until it finds another component in the render function. It'll treat this as a boundary, and it'll stop there. This is what you're going to want to use most of the time. Mount will do the same thing, except when it gets to a subcomponent, it'll keep rendering that until it finishes the tree. And then static sort of renders it to a string. We're not going to talk about it much in this talk, but most of the time you won't actually need to use it. When you're writing your Redux tests, I want you to all try to always use shallow first, and only when it doesn't work, then switch over to using mount. This will end up making your test more robust, because if a child component changes, that will have no impact on the parent component's test, because it was never rendered in the first place. I also like using default props as a test theme. Here we have the audio player component again. When we click the play button, it's going to try to call play on an audio element. In my production code, it uses the default props to get the audio element, which is just using document.create element. You might notice that I'm using an ES5 getter here. That's just to ensure that if I have multiple components on my page, that they're all going to get unique audio instances. Here's how I might test it. I create my test. It should play the audio element. First, I start by making a fake audio element. It's just an object with a play method, and the play method is a mocked function. I can pass that into my audio player when I'm rendering it with Enzyme, and then I can look for the play button. When I simulate the click event, I can add an expectation that the play method isn't called on the audio element, and I can run that test and see that it passes. This way I'm validating that the internal behavior is doing what I expect, but in the production code, it's just going to use that default props. A lot of the Enzyme documentation follows this pattern where you can search for a subcomponent by importing that component into your test, passing it into find, and then it'll return the component. I find I don't like that pattern too much, because when I go and refactor my code or move where that function is, that component is, my test will break for no real reason. Another thing that works is you can pass in a string with the component name, and it'll still return the same, it'll still find the same component. I find this to be easier and just reduce the long-term maintenance on my tests. By now, you shouldn't be too surprised that I'm advocating to test your Redux components in isolation. I like to make a helper function that'll bundle up my React store with all its reducers, any sort of enhancers or middleware, and I can reuse that in all of my tests. I also like to test everything together in terms of my reducers, my selectors, and any sort of action creators. I've tried testing, unit testing them individually, and I just haven't gotten much value out of having individual tests for reducers and selectors. And I find that when I test them all together, I'm really testing the API that my Redux code is going to be exposing to the rest of the app. So here's a simple test. We can see my create store function loading up the store. Then I make a simple episode object. It's just an empty object because the reducer doesn't really care what it is. I dispatch an event, update records, with an array of that single episode. Then I can use my selector to get the state out and assert that it's what I expect. So I've talked about testing components and testing Redux in isolation. But our app is more than that. In the app, Redux and components are talking to each other all the time. Plus, there's so much more app code there. That's why I want to talk to you about acceptance tests. You may have also heard the name end-to-end tests when working with other frameworks. But these are basically high-level feature tests. They make an assertion that this feature exists in your app, but they don't get overly concerned with all the details of the conditionals and edge cases. Those are better solved in more isolated tests. The thing I like to tell myself when I'm writing them is to just focus on the happy path. So here's an example of an acceptance test. I say, it should show a list of episodes. Then I'm using a visit helper here. Basically, it just boots up my app. It uses end-to-end mount. This is the one case where I think it's OK to use it because I want to integration test the entire app. It also has some smarts, so it can wait until any data is fetched before it returns the page. Then I can go and make a simple assertion. I can say, after all the data is ready, I expect to find 4 episodes. And if I look for the first episode, its title should be the political question. This is just kind of a look inside the simple visit helper. One thing you might notice is I'm using fetch VCR here. I like fetch VCR because what it does is it records all of my fetch requests and saves them into a fixture directory. This way, when I run my tests locally and I run them later on CI, they're going to get the same results. If your backend API ever changes, which I'm sure we all know almost never happens, right? You can just delete the fixtures directory, rerun your tests, and it'll record a new set. So when we run our tests, we like to get immediate feedback in the form of red and green error messages in our terminal. And when we write our test, we get feedback about how easy or hard it is to use our API. And isolating our tests helps us improve the feedback cycle by making it shorter and more accurate. But it's also possible to get too much feedback. One thing I see a lot of people do when they're testing is when they make a change, they rerun their entire test suite. This really slows you down, because most of the time, you don't care about 99% of the tests that get run. So I want you all, on Monday or Tuesday, when you go into work, to spend some time to figure out if you can make your editor run all the tests for a single file, just the file you have open, and figure out how to do that with just a button click. There's lots of plugins for editors. You should be able to figure it out. The way to do it usually is if you're using React app, you can just do npm run test and pass in the name of the file, or you can use jest and also pass in the name of the file. And I know jest tries to be smart, and it will filter out, it'll only run the test for the things that have been impacted by your change. But I even find that's too much sometimes. I like to just focus on one test file at a time when I'm actively developing and seeing how my changes are impacting that file as I try to get it to green. Here's an example of my workflow. So I have a key command. I can start up the test for this file. And they take a little bit to start. Most of that is just startup and parsing JS DOM. But once it gets going, it's pretty quick, and it'll watch for changes. Then I can go into my component, start editing it, add a button, run my test will rerun when I save. And I can see that I'm making progress. Now I can go and add the onClick handler. The test will rerun again, and I should see that it works. What I'm not seeing is the $600 tests in my test suite, because I don't care about them. All I'm focused on is making this test file pass right now. So it's time to see how outside-in test-driven development works in action, now that we've learned about all the pieces. We're going to start with a failing acceptance test, and then we're going to use that to write our first component test. As we write our tests, we're going to do them first and use them to drive out the functionality of our components and reducer. Then when we're done, we can go back up to the acceptance test, and we should see it green. Let's see how it works. Here's our podcast app again. List the episodes. You can hit the play button, and it will show the podcast playing at the bottom. Unfortunately, this is what it looks like today. We have no play button. So we're going to start with our failing acceptance test. It should play an episode, boots up the app, visits the index page, finds the play button, clicks it, and then it looks for the audio player and expects to have a class playing so we know that it's playing. We run our test, we see that it's failing, but that's okay, this is what we expected. We know our episode component doesn't have a button, but we don't want to add that yet. First, we want to write a test for our episode component. So let's do that. Write a test, it should call play episode when clicked. We say we're going to mock out a play episode method using just mocking, and we're going to pass that into the wrapper for the episode. Then we're going to call click on the play button, and we're going to have an assertion that we expect the play method that we've passed in as a property to have been called. We run our tests, and we get an error. Method props is only meant to be run on a single node, but 0 found instead. This isn't a great error, but if you work with events out a bunch, you'll start to recognize what it is. Basically, it means we tried to find an element, but we couldn't, and that's because our play button's missing. Now we can go into our component, and we can add it. We can rerun our test again, and we get a new error. We're making progress. Should have called the mock function with the episode, but it was not called. Well, that's easy enough. We can add an onClick handler to our play button. Take the play episode prop that's being passed in and call it with the episode. Now if we rerun our tests, they should be green. If we jump back up to our acceptance tests, we see they're still red, but we got a new error this time. Expected empty set to have class name of playing, but instead found none. What that's basically saying is it's trying to find the audio player and it's not showing up yet. That's because our audio player, despite the fact that our button exists and you can click it, it's not telling the audio player that an episode is selected. To do that, we want Redux to share that state. So we can write a simple test for that. We boot up our store, create a mock episode, and then we dispatch the play episode event. Once that's done, we should expect if we use our selector that we can get the episode, the playing episode that we had selected. Write our test, try to run it, get an error. Expected empty object to be undefined. Our empty object here is the episode that we're using in our test. We know that's because if we go into our reducer, it's not implemented yet. So we can start to implement that. It's not too hard. We have an action type for play episode, and it's just going to update the state to hold the episode that was in the action. Once we run our tests, they should pass again. But if we run our acceptance tests, it's still not working. That's because the component and Redux are still isolated. So we have to write a little connect glue to plug them together. We use connect from React Redux to do that by making a simple map dispatch to props object that's going to have a play episodes property, which is going to be a function that takes an episode and dispatches the event play episode with that episode. Everything should work now, right? Unfortunately, if we run our episode test again, we get a failure. Could not find store in either the context or the props of connect episode. So what this means is our tests are looking for the store because they're using that connected episode component. But as I've been saying, I like to try to keep these separated. We don't want to have to pass in a store or set up a provider in our tests. So what we can do here is on this page we actually have two components. At the top we've got the unconnected component, and then the export default is the connected component. If we add a named export for our unconnected component, we can use that in our tests, and they should run just as they did. We just go back to our tests, update the import, and instead of using the default export, we change it to use the new named import, run our test again, and everything should pass. Now if we go back up to our acceptance tests, they're passing too. And if we go to our app, we should see that everything is working. So, sorry about that. So in summary, I want you all to try writing some acceptance tests for your app and use them to drive out your features as you go. But don't go too overboard at the acceptance test. They're often going to be the most brittle test in your suite, and they'll take the longest to run. So just try to stick with the happy path and treat them as a claim that a feature exists, but they're not overly concerned with that all the edge cases are handled correctly. You should do that in your isolated component tests, closer to where the logic actually is. You want to focus on writing your tests first before you write your components, and kind of use that to drive out the functionality of your component. Like you saw us going through the example, we added the button first, and then later came back and added the onClick handler. And then finally, please don't try to rerun your entire 600 suite test suite for every change you make in the code base. Just try it out, run one test file at a time, and see how that impacts your workflow. Thank you.
Let's do like 5 minutes of Q&A, and then we'll take a short break.
You didn't mention just watch capabilities. Can you use those?
Yes, I do.
And as a substitute for the only running one, how does that relate to just explicitly just running one test file at a time?
Yeah, so sorry. The question was about how do I use just watch capabilities, and how does that relate to running one test file at a time? I do use just watch functionality. I find just starting up just itself is real slow, but once it gets going, the watch is pretty fast. And so I'll typically start the watch with the file name, path of the file that I want it to just run, and then it'll just watch that file and keep running changes there.
So the acceptance is pretty interesting. I didn't see a particular style before. Do you typically also augment that testing with additional in-browser testing, or is that sufficient for your use cases?
This is sufficient for my use cases. I found in browser testing, especially to get up to that level of Selenium, it becomes a little too brittle and too slow to kind of use for active development. So it's kind of like the highest level you can do it in just JavaScript because I get that fast feedback cycle. Yeah, the question was about do I use browser testing to augment acceptance tests?